Have you ever thought about how fat loss happens? I don't mean what you do to lose weight over time. In other words, diet and exercise, whatever that means. I mean, what's the physiology of fat loss? How is it you can be like my friend Vaughn here, who weighed 210 pounds, and a few months later only weighs 170 pounds? Now, we're not going to talk about what he did to achieve that fat loss, in other words, his diet program or his workout program. What we're going to talk about in this series or in this video is what actually happened physiologically that allowed that weight loss to occur. Why is it he implemented or he put into the earth 210 pounds of pressure? Now, all of a sudden, he puts only 170 pounds of pressure. Another way to think about this is, how is it that he literally occupied this much space in the world, right? He used to be out to here. Now he's only out to here. How did he physiologically rid his body of that extra space? In this episode of 55-Minute Physiology, we're going to dive hard into the paint on fat loss. We'll talk about the actual physiology and a little bit of the biochemistry of it. We'll talk about the training implications, some diet implications. And the reason I want to do this video is because once you understand the foundation or the physiology of it, you'll understand which training method is most effective, what type of diet you should do, and what to do when you get presented with new information or when clients ask you things like, hey, this is what I want to do for fat loss, will this work? Or, more importantly, I heard this is how it works, I heard this is what's going on, I heard I should do this program because this reason, is this true? So that's what we're going to answer in this series. Now, as you're going to start noticing from the 55-Minute Physiology series, some of these things are not necessarily 55 minutes. Some of them are 35 minutes, and in this case, it's probably going to be more like a couple of hours. So we'll split it up into multiple parts so we can really understand what's happening with the physiology of fat loss. So how is it my friend Vaughn here lost all of that fat? Specifically, how did it get off of his body? How did he rid himself of that fat around his neck and his ears and his fingers and his back pad? Because we all hate that nasty fat back, right? How is it? I want you to think about right now, take a second to consider, how is it physiologically possible that his body got that stuff off of him? Did he maybe pee out all that fat? Well, you actually do pee out a tiny little bit of it, but that's not really it. Someone who's going through dramatic fat loss like that didn't just have a lot of fatty pee over months and months. Did he maybe poop it out? Well, again, turns out anyone that's actually eaten an extremely high fat diet when they weren't used to it can tell you that you can definitely poop out some fat. But that's not, again, what we're talking about. He didn't just poop a lot more over 3 months or whatever it was. Did he sweat it out? Well, it turns out long-term fat loss is not a result of sweat. Now, of course, you can lose a bunch of weight very acutely, especially in the case of someone like an MMA fighter or a wrestler can dehydrate themselves really quickly. They can lose a bunch of weight. But as soon as you drink water back again, those numbers are going to come right back to the middle. You're not actually losing fat that way. You might lose some weight on the scale for a few minutes, but it's not really fat. So if I don't pee it out, I don't poop it out, and I don't sweat it out, how do I get it out? Well, I need you to do something for me. Hopefully you're not driving while you're listening to this. Hopefully you're sitting somewhere. And if you can, I want you to go ahead and do the following. On the count of 3, I want you to take a big, deep breath in. 1, 2, 3. Congratulations, you all just got a little bit skinnier. You can send your checks in the mail right on over. I'm your personal dietitian and personal trainer. That's right. Fat loss happens through respiration. You, or in the case of our friend Vaughn here, had extremely fatty breath for a long time. Make sense? I don't think so. We got to go into the details a little bit more. How is it that I can lose fat by breathing? Now, some of you are very clever out there and you're probably thinking, wait a minute, if that's true, could I just lose a bunch of weight by and just panting like my dog Ghostface? No, right? Actually, it's true. That's exactly what you do. That is exactly how fat loss happens. Oh my gosh, right? Somebody go ahead and put it out there on Instagram, new fat loss hack. Just breathe, right? Well, it's kind of true and it's not true. Because what would happen if you just sat there and went, if you hyperventilate, you're probably going to pass out or get really lightheaded. But can you think of a situation in which your respiration rate is elevated, but you're not passing out? It's exercise, right? Which is sort of funny because if we go back to the beginning and we talk about our very basic prescription for fat loss, diet and exercise, right? Well, in one respect, that is about as specific as you need to get, because all you really do have to do is some form of exercise that makes you breathe. If you do it enough, if you do it long enough, and if you're patient enough, it's going to technically work. Well, in order to really understand this, we need to dive a little bit into the biochemistry and the physiology of what's happening here. Now, to understand how breathing makes you lose fat, we've got to zoom in all the way down to the level of the individual atom. Up here in the corner, what we have to understand is your basic macronutrients. Okay, now, in our context, the only macronutrients we're going to talk about are carbohydrates, fat, and protein. There's a couple more, but this is the most part of what we're concerned about. If I use our piece of bread here or our bun to represent carbohydrate, I'll use this cheese to represent fat. Now, I know that there's some protein and fat, but don't get lost in the woods here. We'll use this burger here, the meat, to represent protein. I know there's fat in there, but just don't worry about it, right? So we've got one picture to represent our individual macronutrients. Well, what most people don't necessarily realize is that all of these macronutrients, for the most part, have the same molecular makeup. And specifically what we're talking about here are the fat and the carbohydrates. Both of these molecules are long chains of carbon. In other words, they are hundreds, if not millions, probably, of individual carbon atoms attached together to make a big long chain of carbon. Now, in the case of carbohydrate, specifically when we talk about glucose, which is one of the simple forms of carbohydrate, that is a 6-carbon chain. All right. Fat has a different structure. It's got usually 3-carbon chain backbone, and then it's got individual chains alongside of it, which we call fatty acids. And those chains are simply big, long chains of carbon, with each one having anywhere between like 6 and 20 carbons on it. So for one molecule of carbohydrate, we typically have 6 carbons available, but for one molecule of fat, we have 20, 30, 40 carbons. All right, protein is a little bit different. In fact, it's not a major player in energy metabolism, so we're not going to worry about it too much. It does have some associated with it, but it's a little bit different. We'll talk about that in other videos. Okay, so if we're looking at these carbon chains, now what we also have to remember is whether I'm talking about food in this particular case that you consume, or I'm talking about the actual food already in you, it's the same thing. Remember, if we're talking about a piece of cheese or a hamburger as being food, all that means is it's another animal we're making food, just like another animal could make me food, right? So we're talking about the fat on your stomach or the fat on your plate. It's the same damn thing, right? This used to be someone else's bicep or glutes, right? It used to be another animal's, and we made it food, but they could tear us to pieces, put us on a grill, and we would be the same thing, right? So I'm saying that to say that what we're talking about here, I'm using a picture for, in this particular case, of actual food. Well, if I change that picture to be something like this is 5 pounds of human fat and 5 pounds of human muscle. Same thing, right? So whether we're talking about, hey, I want to lose some fat on my body, I've got love handles out to here, I want to lose them. The physiology or the mechanics of the chemistry anyways are the same to burn that pack or that big chunk of fat as it is to burn the fat I eat in my stomach, okay? So we don't have to get lost in those mechanics very much. So as a general overview again, we've got these molecules that are big, long chains of carbon. Now, in the case of human metabolism, what happens is we go to the end of that chain and we break off one of those carbon molecules. Now, in this particular case, the amount of energy I had to put into the system is less than the amount of energy I get out of the system. So that's a net positive result in energy gain, right? I put a little bit of work in to break the bond, but I got way more energy out after I broke it. Boom, I get energy. In the case, again, of human exercise physiology, we'll then use that energy to produce things like exercise and movement, whatever it happens to be. But then we're left with a bit of a predicament. We've got this free-floating carbon around. Your body doesn't like that. Essentially, or almost effectively, what it does is create an acidic environment. And so your body says, okay, we just did this, we gained energy because you told us you needed energy to climb that wall or to pick up that stone or to, push that rower up and down or whatever you're doing. But you caused us to have this free-floating carbon around. What are you going to do about it? You got to get it out of here, right? It's that drunk friend at the bar. Get this guy out of here. Well, your body says, well, you know what? I know this guy is drunk and he's an embarrassment to everyone. He's really irritating. He's annoying, but he does have a friend who will come pick him up. Let's call his buddy O2. Right? Oxygen, or O2, is what's floating around in the environment. And so you have broken this bond in your body. Now you've got this free-floating carbon around. And then you do this. And you take a big, deep breath in, and you bring in a bunch of O2. Right? So we introduce O2 into the environment. Right? That O2 will then bind to the carbon, forming carbon dioxide. We then go and exhale and rid ourselves of the carbon. So to recap everything we did, we took a big deep breath in, brought in O2, broke off a carbon molecule from our fat pad, took that carbon, bound it to the O2 we just inhaled, and then got it out of our body in the form of carbon dioxide. That carbon dioxide has a physical, real-life, measurable weight, and so the amount of weight I lose is directly equal to the amount of carbons I exhale. This whole process of breaking these carbon bonds to give us energy is what we call metabolism. Right? We've all heard of people that have a fast metabolism or slow metabolism. It's really the same speed in everyone, but some of us just are more active, have a more active metabolism or less active metabolism. But this is all we're really talking about. Now, if you take a chemistry class or a biochemistry or even an exercise physiology class, you'll learn about the minutia of making the energy from those breaking of those carbon bonds, because it is a little bit different. But at the surface level, that's really all we're talking about. Since we just rid ourselves of one carbon dioxide molecule, the length of our carbon chains, whether this again be our fat stores or our carbohydrate stores, the length of those got smaller, so you can see that being depicted in our picture up here, they get shorter. If I were to continue this process again, so do something else that required energy, I will cut off another carbon dioxide, it'll bind to some more O2 as long as I keep breathing, and the length of that thing will keep getting shorter and shorter. So all I need to do is put myself in a place where I have a net greater energy demand than I have energy availability. So I do something arbitrary like go for a run, lift some weights, throw some kettlebells around. That tells my body, give me some energy, it breaks some bonds, combines with O2, we breathe it out, our fat pad and sugar pads get smaller. So that's all we're really looking at. Without getting into too much detail here, and we'll get into some later with metabolism, but what we're really saying here is the net end product of all your macronutrient metabolism is CO2, ATP, and water. So the pictures I'm using represented down here, right, whether we're talking about carbohydrate, all of the carbohydrate in your body, when you fully metabolize it, it ends as only three things. Carbon dioxide, which you breathe out, water, which you use, and this molecule called ATP. That's it. The same thing with fat or protein for that matter. Once you finish metabolizing all three of these macronutrients, there's only three possible options, and it will be the same every damn time. They're all working together to make this same ATP molecule, which some of us call the energy currency of your body. The ATP molecule is what you actually do to make the energy, and it's the only option you have physiologically. There is no other way to make biological energy other than making ATP. So I use this to tell you, when we start thinking about this, when we start trying to answer questions from clients or from parents or for yourself, and we start saying things like, well, what is the best way to burn fat? Or what is the best diet to lose fat? Right? What type of workout should I do to maximize fat burning? What we have to realize is, okay, you know what? All of it is coming out as CO2. So your answer to that question is this. Look, anything that simply makes you breathe or enhances your rate of respiration will make you lose weight. Now, in some of our other classes, we will talk about how some systems are a little bit more efficient, some are better at adherence, but what we're really talking about here is I will guarantee you one thing, 100% money back. If you're trying to lose fat, if you put yourself on a training program that you like, so let me restart this. Trainers, coaches, if you're working with an athlete, the single most important variable you can do for someone who's trying to lose weight is make sure you can maximize adherence. In other words, put them on a program that they will do the most and that they will work the hardest at. So for some of your clients, that may mean you have to put them on an elliptical for 30 minutes a day. Some of your clients, that may mean never ever do a 30-minute run, right? Design them a workout that they like, that they will work the hardest at, and that they will stay with, because anything that makes them breathe will make them lose weight, right? So they have the option. Say, just to make up numbers, and these numbers are not right, but it gives the idea. Say in order to lose 1 pound of fat, you have to take 500 exhales. Again, those numbers are way off. I'm just making a point here. Now, you can choose to do your 500 over the course of an hour if you wanted to go for, like, say, a very light jog. Your respiration would go up a little bit, right? Instead of breathing at this normal pace, 10 breaths a minute, maybe you well, I would get to 500 eventually. It might take me an hour though, right? But 500 is 500. Or maybe I decide to health it. I don't want to waste an hour. I'd rather go sprint up that hill or that mountain as fast as I can, make my breath do this, and it would maybe take me 10 minutes to get 500 in as opposed to an hour. Well, chemically, it doesn't matter a whole lot. Again, that's not to say those training programs are identical, but they probably differ a lot less than they are similar. So when you're talking about working with your athletes or clients, find what they like to do, what they will work the hardest at, and what they will do the most frequently. That's what's going to get you the best long-term success for someone who's not, say, a professional athlete who doesn't have endless resources. We need to jump in a little bit more and start talking about the sources of cellular energy. So in other words, back to those macronutrients. How do I actually go from a piece of carbohydrate or a piece of fat that I ate, my piece of fat here, and produce cellular energy so that I can power exercise and power human movement or anything else I need energy for? Okay, as a quick analogy or a quick way to think about this, what I want you to do is think about the 4 sources of energy in your body. Now, again, this is a quick overview. This is not every single thing, but this is the vast majority of what you need to know. Your 3 macronutrients we've already talked about, but I also want to talk about phosphocreatine. Now, it in and of itself is not an actual macronutrient. If you watch the 5-minute physiology video on this, you've already heard me discuss that. But I like to think of it as a macronutrient because it makes more sense the way that we process it and use it to produce energy. Now, right away, like I mentioned before, all of these things are coming together to try to make the same molecule, ATP. ATP stands for adenosine triphosphate, which you can see here, 1, 2, 3, triphosphate. It's got 3 phosphate molecules attached to this adenosine thing. Well, as I mentioned, we'll talk perhaps later videos about protein as a fuel source, but generally we like to use protein as structure or building material, not necessarily fuel. So let's just go ahead and take that off the list for now so that we can not get too worried about it. And we'll talk about our 3 primary fuel sources: fats, carbohydrate, and phosphocreatine. As I mentioned, they're all trying to make ATP. Once we have ATP, we can then split that ATP into what's called ADP. So you've gone from adenosine triphosphate to adenosine diphosphate. You can see that phosphate, that inorganic phosphate, is then floating around free. That net result right there, just like when we broke the carbon bond, right? That gives us a net result of energy, right? In fact, it also gives us a bunch of heat, and depending on who you ask, something like 60 to 70% of the energy produced from that reaction will result actually in heat, not necessarily energy. But nonetheless, that's why you actually get hot. That's why you warm up when you exercise a lot. But whatever remaining energy is available, we will use that to power things like human exercise, right? So you see me there on Torrey Pines crushing it on probably, I think that was probably the first hole. If that's the hole, I actually put it in the bunker far to the left, and then I had to chip way out into the other bunker, actually another fairway, deep woods, and then I hit like a 200-yard shot out of the deeps onto the green, over top of a bunker, then put it in for par. It was incredible. Right? I'm not a great golfer, so that was amazing to par the first hole at Torrey Pines. Anyways, right? So we're trying to use that energy to power exercise or whatever else we want to do physically. Whether we need to grow new immune cells, we need to produce red blood cells, we need to communicate your brain, astrocytes, your nerve system, your red blood cells themselves go through anaerobic metabolism. So whatever it is we need to do. At this point, I want to take a little bit of a pause and go hard into some bioenergetics. So those of you that have had a little bit of exercise physiology, I think you'll really like this next section because we're going to try to cover everything that you learned in exercise physiology and do it once over a slide. If you haven't had it, I think this is actually going to be really exciting to you because you're going to see and a lot of things you're going to click and go, oh yeah, that's why. So take a deep breath if you have to. Go grab a drink of water, refuel the coffee. Whatever you need to do, put yourself together mentally because this is going to be a little bit of a dive here into this next section, which is what I call the summary of all bioenergetics. All righty, here we go. Let's dive in. Let's assume you had a big meal. Okay, now it doesn't necessarily matter what that meal is, but let's just say it was a mixed macronutrient meal. So in this particular case, a delicious hamburger. Right, with you'll have some fat in this meal, you have some carbohydrate and some protein. Well, that's going to actually sit in your gut as an actual piece of food, right? But by the time it leaves your gut and gets into your blood, it's no longer in these macronutrient form, or sorry, no longer in this food form. It's actually broken down all the way into its macronutrient components. So in other words, if I draw your blood, I don't see, oh, you ate a hamburger. I just see, oh my gosh, blood sugar's gone way up. There's a lot of fat in the blood. There's a lot of protein in the blood, all right? So the first step that actually happens is your gut breaks down that food into those individual macronutrients, and it sort of separates them out. Now, as we showed earlier, that will release an excessive amount of energy, depending, in fact, the amount of energy released differs between those macronutrients. But you will get a little bit of usable energy that you can then from there go on to either produce ATP or it'll come out as heat. Okay, and if we start with carbohydrate first, and I'm going to do this because I think it's the most important, it's the most prevalent. Again, remember, in your blood, the blood glucose floating around in your system is in the 6-carbon chain form. So you got 6 carbons floating around, and I don't care that you know that necessarily, but I want you to pay attention to these carbon counting because it'll make sense at the very end, I promise. In fact, this entire 55-minute physiology series will make sense if you pay attention to the carbon counting now. So we got 6 carbons there, which I'm representing, and I think there's 6 in that pack. From there, I'm going to go through a process called glycolysis. Now, it is exactly what it sounds, glyc, meaning glucose, or glycogen, which is the stored form of sugar, and lysis. Anytime you hear the word lysis, that means to break apart. So glycolysis, quite literally, is the metabolic process of breaking apart glucose or glycogen. As a result of that, again, we broke more bonds, right? Those carbon chains we broke off. We will get some things that we were able to use to produce ATP. And we'll get this other molecule, NADH, which we'll talk about a little bit later. Now, what actually happens is that glucose molecule, if you picture it to be a 6-carbon molecule, gets actually split up into 2 separate 3-carbon molecules called pyruvate. In your image here, I'm only showing 1 pyruvate, but in reality, there's actually 2. So we just split it apart. You know, we didn't lose any carbon dioxide yet. We just took a 6-carbon molecule, split it in half. Each one of those 3-carbon molecules, though, will get then further split into a molecule called acetyl or acetyl-CoA. Now, those molecules are actually only 2-carbon things. So you'll notice we went from 6 to 2 sets of 3 down to 2 sets of 2. We lost 2 carbons right here. Right? And so there we go. There we have immediately lost ourselves 2 carbons, and we just started the process of breaking down a carbohydrate. The acetyl-CoAs that you form, those 2-carbon molecules, will then go through a process that I'm labeling TCA here, which people often refer to as the citric acid cycle or the Krebs cycle. And each one of those 2-carbon molecules will get its own individual spin, and they'll go through, and as a result of that, you'll make a bunch more ATP, you'll make some of these NADH molecules, but more importantly, you get a net result of 2 carbon dioxide molecules per turn. All right, so to wrap that whole thing together, when I talk about carbohydrate metabolism or glucose metabolism, I start with a 6-carbon molecule. I break it down into 2 3-carbon molecules. Each one of those gets broken down into 2 2-carbon molecules. I exhale 2 carbon dioxides. This gets a turn through the Krebs cycle, which net results me in 2 carbon dioxides, and then this gets a turn, and I have 2 carbon dioxides, so I'm left with no carbon. I metabolized carbohydrate. I got left with ATP, water, and some carbon dioxide that I breathe out as waste down here. If I have sufficient O2 available, the things that are left over at the end of the Krebs cycle will then go on to a thing called the electron transport chain. I'll produce a net result of water, which I'll use for waste there, and a whole bunch of more ATP. If you've had Phys class, you may remember that number is like 37, 38, 39, something like that, ATP. And I'm left with my final end product once I have fully metabolized carbohydrate as ATP, water, and carbon dioxide. And now I've fully metabolized a molecule of sugar. All right, let's move on and talk about fat. Now, as I mentioned, for the most part, fat is stored a little bit different than carbohydrate. So when you have carbohydrate in your body, it's essentially stored in two forms. It's stored in the form of glucose, which is that 6-carbon molecule, and that's primarily when it's in your blood. Right? So blood glucose or your blood sugar levels. Now, when we take that and we store that in either the muscle or the liver, and we store it as glycogen. So what we do there is we take a bunch of glucose molecules, pack it together, and store it. All right? So if I have 100 grams of glycogen, that means I literally have thousands or millions of carbon atoms stuck together, and I can break them out as 6-carbon chains, put it in the blood as blood glucose. Well, fat has a similar storage mechanism, right? Now, what we typically do to store fat is put it in subcutaneous, either intramuscular as intramuscular triglyceride or subcutaneously or other places, and we call that adipose tissue. We store adipose tissue in the form of triglycerides. A triglyceride is exactly what it sounds like. It is a triglyceride. So this means it is a molecule that looks like an E, right? It has a shape like that. The backbone of the triglyceride is a 3-carbon glycerol backbone. So you can see here, 1, 2, 3 carbons, glycerol, and then you've got a bunch of fatty acids. So if you can picture 3 carbons, and from each one of those carbons you attach a big long fatty acid chain, right? So you have 1 glycerol backbone and 1, 2, 3 fatty acids. The length of each fatty acid determines what type of fatty acid it is. So is it a 12-carbon chain? Is it an 18-carbon chain? That's what's going to make it something like stearic acid or olive oil or different types of oils or fats, right, are determined by the length of their carbon chains. So the first step in metabolizing fat is to go through a process called lipolysis, in which I split a triglyceride into its glycerol backbone and its 3 free fatty acids. Now that happens actually in the entire system, not the exercising muscle, which we'll talk about in a second, but it requires oxygen, and it is an aerobic process. So I've got my fat, and I've split it into my glycerol and my 3-carbon fatty acids, or my 3 free fatty acids. Now what happens here is identical. So what we have to realize is once we move past pyruvate and we move down, that entire process of metabolism is aerobic. That all happens in the mitochondria and is shifted over. So some folks fail to realize that we actually oxidize carbohydrates. Which is another way of saying, when we tend to think about oxidation or aerobic metabolism, we think, oh, okay, let's see, I burn fat for aerobic metabolism and I burn carbohydrates for anaerobic metabolism. Well, that's fundamentally not true. It is true that you only have one option with fat, which is aerobic metabolism, but carbohydrate is started anaerobically, right, here to here. This process of glycolysis is 100% anaerobic. But in order to finish or to fully metabolize that sugar molecule, you have got to finish aerobically. Well, it turns out it's the exact same system. So once you understand the aerobic metabolism of carbohydrate, it is the exact same as the metabolism of fat once we split it into its individual parts. So for example, the glycerol is a 3-carbon chain, which means it can be treated almost identically or exactly like pyruvate is. So it'll get turned into acetyl-CoA, it'll go to Krebs cycle, etc., etc. The free fatty acids are a little bit unique, and I'll skip some steps here, but they are transported into muscle. They get pushed into the mitochondria, like all this stuff is here. We're all in the mitochondria at this level. And it goes through a process called beta oxidation, in which we take that big, long 18 or 22 carbon chain and we cut it into 2 carbon molecules, 2 carbons each. This is why they call it beta oxidation. Then once I'm in the 2-molecule form, I'm acetyl-CoA. So then I can run it through Krebs cycle. We go through the electron transport chain eventually, and we make all these ATP. Now, as a result of that, or in lieu of that, if we take the fact that when we break down 1 molecule of carbohydrate, that's only 6 total carbons, but 1 molecule of fat is, like I said, 20, 40, 60 carbons. per one molecule, I'll get way more ATP out of fat. But that's a bit misleading, right? We've known this for a very long time. In fact, a paper came out just last week that showed clearly if I enhance the rate of oxidation of fat, that doesn't necessarily improve performance in aerobic sports, right? Because our ability to produce energy during aerobic endurance is not limited by our rate of lipolysis, right? It can be limited by our rate of oxidation, but not lipolysis. So in other words, you have plenty of aerobic means available. You have plenty of fat available. If I give you more, if I put you through a training program or a regimen that enhances your ability to burn fat as a fuel, that doesn't necessarily mean you'll perform better at aerobic sports. Now, just to round out our picture here, let's talk about the breakdown of protein as a fuel source. Now, as I mentioned, it's not a massive contributor to exercise metabolism, so it's not a big deal. But in case you were wondering, kind of essentially what happens is when we take sugar and we pack it together, we store it and we call it glycogen. When we take fat molecules and we pack it together, we store it and we call it adipose tissue or a triglyceride. When we take amino acids together, smash them together and store it, we call that a protein. So it's a similar version, and it's not exactly how it works, but it's pretty close. So if we take that the backwards version of that, or come back the other way with that, if we want to break down protein to use it as a fuel source, what we're going to do is break it up into its individual amino acids. Now, that can actually get broken down into a 3-carbon or 2-carbon molecules, depending on what you do. But in either case, they can get shifted and put in through metabolism, just like pyruvate or acetyl-CoA. And then you're running through the same process. So like fat, protein metabolism is entirely aerobic for the most part. So you need to start this thing, it requires oxygen in order to happen. As a byproduct, you will also make this little molecule called NH2, which is essentially ammonia. And this is why for years bodybuilders have been concerned with things like their nitrogen balance, right? Because it gives them an indication of are they at a net gain or net loss of protein, right? Now, it turns out that nitrogen will be excreted through your urine, which is why you can, you have the problems with the urine smell of people that are on extremely high protein diets, and I mean extremely high protein diets, not just eat a lot of protein, right? Because it will be excreted as waste. So you've got the basics of bioenergetics here. You've got everything down there. We're going to use this to paint the picture, or to complete the picture that we started painting of the real physiology of fat loss. And as we continue on, we're going to start applying this knowledge to exercise routines. So keep this stuff in mind as we move forward. Now that we understand the process of glycolysis or lipolysis a little bit better, we understand how we use those macronutrients or these sources of fuel to produce cellular energy. Well, it's time to actually expand on this a little bit. So at first, understand phosphocreatine, for example, is purely anaerobic. In other words, it does not care if oxygen is around or not. It doesn't need it. It's not even required. On the other end of the spectrum over here is fat. Now, fat is purely aerobic. In other words, it will not happen unless you have oxygen available. And then, of course, in the middle, you've got carbohydrate, which doesn't need oxygen to start, but in order to finish or fully metabolize the carbohydrate molecule, you need to have oxygen available. So you've got this continuum, fully aerobic, fully anaerobic, and then carbohydrates, which are in the middle. And this is one of the reasons why being able to use carbohydrate as a fuel is so beneficial, because it can go a little bit both ways. It gives you a little bit more metabolic flexibility. When we start to use these fuels as an exercise, we have to realize that the phosphocreatine and the carbohydrate are coming directly from the active muscle, but the fat is coming mostly from the entire system. So picture yourself, you're doing burpees, right? You're going up and down and jumping up and down, touching the ground, doing this awful exercise, and you just start feeling the burn in your quads. You're using ATP and carbohydrate from your quad. In other words, the individual muscle fibers themselves store this carbohydrate and this phosphocreatine in itself. So it can break it down right there, send it to the myosin and actin, and start using it to power exercise. Well, we don't use fat in that same source. Right? What we have to do to fat is we have to get it from the entire body equally. And this explains one of these common myths that most people are aware of by now, that is spot reduction, which I'll explain to you in just a second. But what we have to do, say for example, as we're doing our burpees and we start to say, okay, look, we're starting to run low on phosphocreatine or carbohydrate source, we need to start using fat as a fuel source. You're not going to take fat from your quads, right? That's the idea of spot reduction. The idea that if my arms are too flabby, I'll just work my arms really hard, I'll burn the fat in that particular spot, I'll reduce it in that area. It doesn't work that way. right? Fat comes from everywhere. So as you're starting to burn in your quads and you're starting to need fuel, or fat as a fuel for your quads, you start to break down fat everywhere. So the back of your neck, your fingertips, your toes, around the quad area, all of it. This is why when if you've ever known someone who's lost weight, especially if they've lost more than, say, 20 or 30 pounds, you realize everything on their body is skinnier, not simply the exercising muscle. Right? If that were the case, if someone lost 80 pounds running, all the fat loss would have come from their calves and quads and glutes. But no, it comes from everywhere, right? And do you ever think about how that happened? Like, how is it possible their fingers got skinnier? You think they did a bunch of, like, these exercises all day? Or how did their neck or jaw get skinnier? Did they, In fact, that's probably exactly what they didn't do, right? They probably stopped eating so much. So we don't lose fat in the exact exercising area, but we do lose carbohydrate in that area. Or in this case, more specifically, when it's stored in the muscle, we call it muscle glycogen. All right, so you can see down here in the bottom, this fat as a fuel, and I won't walk you through everything, but basically what has to happen is you're doing your burpees, your quads are burning. You start to break down fat, say from the back of your neck, some adipose tissue. You've got to go through lipolysis, which is to break that triglyceride apart into its individual body parts, put it into the blood. We have to transport that fatty acid through the blood, and we have to attach it to an albumin molecule. It's got to move it around. Then we got to get it transported into the muscle cell, in this case our quad. It's got to go through the quad muscle and get uploaded and put into the mitochondria. It's got to go through the membrane there. Once we do that, we have to go through that beta oxidation and then the Krebs cycle, and then we finally get some ATP. Well, we do get a lot of ATP or energy from one fat molecule, but do you see how long, can you imagine how long it takes relative to simply using the carbohydrate that's right there? Right? So there's pros and cons to both systems here. More energy from one, but it's much slower. Right? Much faster over here, but a lot less total energy, and I only have a limited supply. Right? The typical physiology thing we teach is the average, say, 77 kilo man who's maybe 20% body fat has probably enough fat on their system to power them to 30 to 50 straight days of exercise. Right? Your fat will never be your limiting factor, but your carbohydrate absolutely can, because you can only store so much of it in your cell. And it turns out your body doesn't really care about maintaining the amount of fat you have on you. It's your backup storage. It does care about maintaining blood sugar, though, and muscle glycogen. All right, so here's what it basically says. If you run blood sugar low or muscle glycogen levels low, we will use our fat stores to replace that. Right? I'm not going to let you walk around with low muscle glycogen if I have any energy available possible anywhere. Right? But if you lose a little bit of fat, go up a little bit of fat, and we don't really care. So it's not a major concern of it. What's the practical implication or application of all this information? Well, I'd say twofold. Number one, people are far too concerned about making sure they work out the exact muscle that they want to lose the fat from, right? Spot reduction myth. What they also are too concerned about is which macronutrient I'm using or I'm burning when I'm working out. As we talked about earlier, and I think we've made this point by now, it all comes out as carbon dioxide anyway, so it doesn't necessarily particularly matter if you're burning fat during your workout or you're burning carbohydrate. Your goal is to simply burn carbon dioxide. I will explain to you this later in the video, why that exactly makes sense, and I'll connect some dots. But before we get there, what I want to do is walk you through what I call the circle of carbon life. This will help put in context the exercise and the nutrition piece. To understand my schematic here, what you have to see is in the top hand corner, anything you see that is green are things that happen in your physical body. The things that are in the blue area are in the atmosphere, and the things in the yellowish, brownish color are things that are in plant. Well, let's remember that in our body, the way that we store fat and sugar are chains of carbon. Okay, now, in your blood, you store sugar, blood as glucose. That's a 6-carbon molecule. But then when you pack that away and you store it in your muscle, you call that muscle glycogen. If you have too much of that floating around too often, your body will say, look, our muscle glycogen levels are packed or full. Let's store all that extra sugar as fat. Same thing will happen if you overeat protein or fat, right? That's not necessarily specific to carbohydrate. But they're structurally very similar, fat and carbohydrate stores. So fat, adipose tissue, carbohydrate is muscle glycogen, which is a big chunk of carbons, or blood sugar. Well, what happens is, like we talked about earlier, you've got these big long chains of carbon. You go through your workout about whatever it happens to be. You do your Jane Fonda or your Pilates or your intervals or whatever you want to do. You breathe in O2, you breathe out CO2 like we talked about earlier. And so now that lonely little carbon molecule has found its oxygen buddy and it is out in space. Well, we as humans breathe in O2, breathe out CO2. And when we breathe out, that means we're literally losing one of our stored carbon molecules. But what we know about plants is they do the opposite. Right? We know this, right? Trees particularly are important because they're the ones that give us our breathable O2. They breathe in CO2, hold the carbon, and breathe out O2. And because they held carbon, the length of their carbon chains get bigger and bigger and bigger, so they get taller and taller. We as humans don't have the ability to extract carbon from the atmosphere, but plants do. So since we can't do that, we have to get our carbon from other places, which is the plants. Okay? So that same carbon molecule that was your fat pad, that is now in the air as CO2, is consumed by a plant. They hold on to that molecule, they tack it onto their carbon chain, it gets longer. Now, just like in your body, when we have sugar floating around, we store it as muscle glycogen. Plants do the same thing, and when we store it in plants, we don't call it muscle glycogen since plants don't have muscles. We call it, ready for this? Drum roll. Starch. Right, that's all starch is, folks. It is the muscle glycogen equivalent for plants. Right? So if we take a plant or a vegetable like a potato, we know that potatoes are very high in starch, which means they have taken all of the sugar, all of the carbohydrate, made it as sugar, and packed it away as these glycogen molecules, essentially. Right? So when we now ingest that potato, it goes into our belly as a potato, it gets broken into its individual carbon dioxide or carbon molecules. We put it in the blood as 6 carbon molecules called glucose, which is why starches raise blood sugar levels, but they do it over time because they're densely packed, and it takes us a while to break down all that glycogen into smaller chunks of glucose. Fruit, on the other hand, is more like fructose or fructose, which is a 6-carbon chain. It's one of your simple sugars, but it's the same thing. So when we ingest those things, they raise our blood sugar levels really fast or quickly because they're already in that identical form, that 6-carbon form. All right? But nonetheless, my point is, starch is essentially the plant equivalent of muscle glycogen, and fructose or glucose in fruits and things like that are essentially the same thing as your blood glucose. So you ingest that plant, those fruits, those vegetables into your belly, right? So now that same carbon molecule is back into you, right? Because some of us don't necessarily realize that the macronutrients in plants is carbohydrate. When we eat meat, we generally get protein. When we eat other sources, nuts and things like that, we get mostly fat. But plants and vegetables are all carbohydrate. Which, for the record, if you haven't heard this yet before, carbohydrates and sugar, it's the same word. All right. So yes, fruits are full of sugar, which is just carbohydrate, and that's not necessarily inherently bad for you. But what happens if you over-ingest sugar? Or over-ingest carbohydrate, or over-ingest fat for that matter? Since it's just carbon, your body says we're stored here, pack it in, and store it away as a fat molecule if we're out of muscle glycogen space. So hopefully that helped you understand a little bit the connection between the carbohydrates you eat, the fat you eat, the fat you burn, the carbohydrates you burn, and we can move on to our next concept. Have you ever been to a gym and seen a chart like this? Right, what this is supposedly telling you is the cardio zone, right? So depending on your age, what you can do is use your heart rate to determine where your max fat burning zone is. Well, this is a real problem. People don't understand this chart, and what this chart actually shows you is a very poor understanding of exercise physiology that by now, hopefully, you understand what's wrong with it. So here's the general myth. You need to work out at somewhere between like 60 and 70% of your maximal heart rate to burn the most fat. Now what this is a trick of percentages, and I'm happy because most gyms are going away from charts like this because it's incredibly deceiving. We talked about this a little bit earlier. Can you lose fat if you work out at 60 to 70%? Of course. but you need to work out for a very long time because that doesn't require a lot of breathing, and we're not exhaling or getting rid of a lot of CO2. But what that doesn't mean is I have to work out in that zone to maximize fat burning, because maximizing fat burning is not necessarily maximizing fat loss. Just because I'm using fat as a fuel doesn't necessarily mean I will lose more fat. So let's dive into that a little bit, and I've come up with a couple of examples just to highlight the idea. So this is a concept that's very important, and it's really the foundation for that chart. So that chart is technically a little bit correct, but in application is totally wrong. Let me walk you through this chart to help you understand this concept. So what you're going to see here is a red line, which will represent the amount of calories that you're getting from, or the energy you're getting from fat. The black line will be what you're getting from carbohydrate. And what we'll do is we'll see how that changes when we're resting, when we're doing some easy exercise, hard exercise, all the way out to maximal exertion. So with the black line here for carbohydrate, what we see is at rest, maybe 40% of the energy you're getting is coming from carbohydrate, with the other 60 or so coming from fat. Okay? Now, that number's debatable, but it doesn't matter. It's something like an even split, maybe 70% fat, 30% carbs, something like that. As you can increase the intensity of your exercise, you start working harder and harder and harder, the percentage of your energy that's coming from carbohydrate starts to go up. And in fact, at maximal exertion, 100% of the energy is coming from carbohydrate. And that makes sense because if you think about a little bit earlier, we talked about when we use carbohydrates for fuel, it's coming from the exercising muscle. And when we use fat, it's coming from everywhere else. And when we're exercising at a maximal intensity, I don't have the damn time to wait for fat. So I'm going to say, screw it. I know I don't get as much bang for my buck here, but I'm using only the carbs I have, which means how long can I possibly go at maximal exertion? Not long, right? Until you have to start slowing down, which is, for the record, why you slow down, is because you don't have enough time to bring in the fat and use it as a fuel. So your body says, slow down, give us some time. Well, when we know that, turns out the exact inverse is happening with fat. So again, at rest, it's something like a split, but as you start to exercise, a lower and lower percentage of your energy starts coming from fat because of what we just described. So people use this to then say, okay, if I want to maximize my fat burning, therefore my workout intensity should be something extremely light. And I understand that. I sympathize with people that think that. Because it does make sense. You might be thinking, hey, well, if I work out in this hard or even max exercise region, I'm not burning fat as a fuel, and that's right, you aren't. Therefore, I won't lose fat. My counter argument to this would be this. If that's the case, you know what what type of exercise you could go do or what activity you could go do that would maximize your fat burning? It would be this, like ghost face. Go take a nap. That's when your heart rate will be the lowest. The percentage of energy you're using will be the highest coming from fat. Now, no one in their right mind thinks that if you just lay around and sleep all day and lay on the couch that you'll lose fat. So clearly something's broken down with this logic of lower the intensity, increase the fat burning. So what's really happening here, it's a little bit of a game of numbers. And I've made some up to help you understand this idea. And don't worry about the exact numbers. I'm trying to highlight the concept. I think you've gotten the point already that you need to move and breathe. So if we took a look and we compared 3 different activity levels. So the first would be resting. So you're sitting here watching this video. The next would be if you ran a 15-minute mile, which for most people is kind of hard, but not too hard. Or you ran a 5-minute mile. And let's say percentage-wise, where did your energy come from? Let's say at rest, you were burning 2/3 fat, 1/3 carbohydrate for a total of 100%. Okay, fine, doesn't matter. And let's say during that 15-minute mile or that 5-minute mile, you burned 100 calories. And without getting into the details here, yes, you heard that correct. You'll burn the same amount of energy roughly. It's just one will take you 3 times as long. Okay? So you burn equal amount of calories. Well, if we look at our percentages here, 66% or 67% of our energy coming from fat at rest, well, as we start to exercise, those numbers start to get lower, and so maybe 33% of our energy at a moderate level exercise comes from fat, and 2/3 of it comes from carbohydrate. But when you compare that to the 5-minute mile, like I said, 100% of it's going to come from carbohydrate. So you might be thinking, aha, like I said, run the 15-minute mile and you will technically burn more fat. Okay, so if we compared our 15-minute mile and our 5-minute mile, who burned more fat? Well, you might think the 15-minute mile burned more fat, and technically you'd be correct, but my counter-argument would be, again, who cares? Both cases you burned 100 calories, and that's what matters. Right? So who burned more calories? It's identical. In fact, you could even probably argue that the 5-minute mile would burn more than 100 calories based on energy and displacement and things like that. But the real question is, who lost more fat? Well, in order to understand this, we have to keep going, right? Because fat loss would probably be about the same between the two, but one of them spent 3 times the amount of time. And if you've ever worked with a client, or yourself, if you've ever missed a training day like I did yesterday, why is it? Right? What's the number one reason people either don't work out or they skip training sessions? I don't have time. So if we want to talk about physiology, that's not necessarily the same thing as behavior. So I would argue that, okay, you might technically burn more fat with the 15-minute mile. It's going to take you 15 minutes or 45 minutes. The other way will burn you the same or maybe even more calories, but will take you a third of the time. And I promise you right now, if you took a client and you said, look, I can get you to lose 20 pounds in 2 months. Do you want to work out 3 times as long or a third as long? For the equal results, they're going to say a third, right? Most of the time. So I want to finish this by going back to the beginning, right? Remember when I said all of those things end up as CO2 anyway. So regardless if I'm burning fat or carbohydrate, it's coming out as CO2. And so anything that makes you breathe makes you lose weight. Still kind of confused? Haven't really put all the pieces together? Maybe thinking, again, I think I get it, but I'm not really buying in because I need to look fantastic in my bikini. Let me walk you through this, the last little piece here. Because we understand the structure of a fat and carbohydrate, what we now can realize is that it is very easy for your body to convert a fat into a carbohydrate. So here's really what happens. You go do your intervals, or you do that ski erg or whatever you have to do, and you do that high intensity exercise that is technically burning 0 fat, right? And all you're burning is carbohydrate, meaning you burn down half of the muscle glycogen in your quad. If you don't consume a huge carbohydrate diet, right, you're not eating something obnoxious, you're not overeating hundreds of carbohydrate calories a day. And by the way, I'm not saying you have to go on a low carb diet. I'm just saying you're eating a normal, reasonable, mixed macronutrient diet. If that's the case, your body will say, hey, look, we've got all this extra fat laying around, but we are low on muscle glycogen. And because, as I mentioned earlier, it cares more about preserving blood sugar and muscle glycogen levels, your body will break down the fat it has, convert it into sugar, and replenish your muscle glycogen. So, although you technically only burned carbohydrate during the workout, you will burn fat in order to replace the muscle glycogen. And that, my friends, is how I can lose fat by only doing high intensity exercise. Right? So, can you do low intensity exercise and lose fat? Absolutely. If you burn fat, you're going to lose some fat, but you don't have to. Right? Just get carbon out, whether it comes from a anaerobic or aerobic exercise means, it's okay either way. Right? So, try super hard, burn as much muscle glycogen or sugar or carbs as you possibly can, and let your body use the fat stores you have to replace the muscle sugar. So which is best? Right? Should I do some sort of steady state endurance, running, cycling, swimming for an hour? What about maybe something like strength training, heavy lifting? Or how about something like circuit training? Maybe some intervals and different things like that. Well, it turns out, again, it comes down to a little bit of adherence. What we have to understand is this. Nutrition is king when it comes to weight loss. You can only do so much from the exercise side of it. I love these 2 articles that came out. You can see them here. The first one is Debunking the Myth That Exercise is an Effective Weight Loss Treatment. Another one, a similar one, is a paper that came out, and I won't read you the title, but basically what these things argue is that exercise itself only provides you the minimal amount of what you need to actually lose fat. Now, this is not saying exercise doesn't work or you shouldn't exercise or you don't have to exercise. Trust me, it will make your fat loss way more successful if you do a lot of really hard work. But what it is saying is this: a bad diet will beat out your great workout program any day. And you can read these papers, but I'll give you the very highlight is what the last one in particular is suggesting is that evolutionarily, it makes sense that your body will actually conserve energy output. So in other words, you go through a super hard workout and burn 1,000 calories. The rest of the day, your body will down-regulate energy expenditure by 1,000 calories so that your daily energy output is identical. So whether you worked out or not, you'll burn 3,000 calories that day. All right? For every calorie you burn working out, your body will throttle down the rest of the day. Now, this is far from a proven scientific thing, but this was published paper and it is an interesting thought. Been some stuff to refute it, to say that doesn't happen. But what it does help people realize is that most of weight loss comes from your diet. Okay, we'll have separate videos to talk about that because exercise is important. So let's focus on what we do know about the exercise. One specific benefit of exercise during fat loss is that it enables you to preserve muscle mass while losing fat. All right, this is critically important, and I'll spend a few minutes talking to you about why exactly that is. So first of all, if we take a look at what's actually happening when you exercise, I like to think about exercise adaptations falling into 5 separate categories: speed, power, strength, hypertrophy, and conditioning. Well, if you look at this list, you don't see fat loss on this list. You may be thinking, am I trying to tell you that fat loss is not an adaptation to exercise? Well, what I'm saying is it is not a direct adaptation, but it is a byproduct. And what I would probably say is it falls somewhere under these 2 realms, or sort of 2.5 realms. Right? In other words, what I'm saying is if you program for hypertrophy and if you follow the guidelines for conditioning, those 2 things will result in a lot of fat loss. And that bracket may even stretch a little bit up into some of the basic strength training stuff. You're probably not going to lose a lot of fat doing what's traditionally referred to as speed work or power work, and I'm not going to get into the details of what that means in this video. You'll have to check out one of the program design videos. I will give you some specific recommendations for what it means to do strength, hypertrophy, and conditioning work a little bit later in the video. But suffice to say, if you do those or some sort of combination of those are probably going to help you achieve your fat loss the most, which is, again, trying to help you maintain or even gain some lean body mass while losing some fat mass. Right? If this didn't matter, we could all just go on a starvation diet. We would lose fat, we would lose a lot of muscle, but we would lose a lot of weight. Right? That's not really what we're looking for. We're trying to preserve muscle mass or slightly enhance it. And why this is so important is we've known now for the last decade or so, thanks to the fantastic work by a Scandinavian researcher named Bente Pedersen, that skeletal muscle is more than about aesthetics and performance. It's what we call an amino acid reserve. In other words, it's the place on your body that holds all of your extra amino acids. Now, why this is critical is because amino acids are the building blocks to proteins. Proteins are, of course, your skeletal muscle and things like that, but they're also the backbone of your immune cells. They're the backbone for your hormones, for your hair, for your red blood cells, for your kidney. So what's happening is, if we have sufficient muscle mass, we have the ability to store extra amino acids. So when we have some sort of insult, injury, sickness, we're able to quickly create the antibodies we need to attack, prevent, and cure our illness. All right? And you can see from the graphic here, you can see the schematic of a skeletal muscle, and you see the contraction, and we now know that contraction causes a release of things called interleukins, these IL-6s. Right? These IL-6s speak directly to your fat mass. Right? And you can see in this particular case, it's activating lipolysis. It's also speaking directly to things like your kidneys and liver, telling it, hey, convert glycogen to glucose and put it in the blood. Or it's telling you to do other things. It can be inflammatory, anti-inflammatory, pro-inflammatory. It can enhance fat oxidation, right? Depending on what it's doing. What I'm really saying here is muscle is actually, in fact, the biggest organ in your body. Right? In fact, you can probably Wikipedia this, and if you just type in what's the biggest organ in your body, you're probably going to hear something like your skin. Well, it's totally true if you ever go on Jeopardy or something, that's going to be the right answer. But the reality of it is, the right answer is skeletal muscle. It speaks to other things. We thought for years that skeletal muscle was stupid. In other words, central nervous system tells skeletal muscle what to do, it just does it. Now what we finally understand, thanks to the phenomenal work by Dr. Pedersen and other people like her, is that skeletal muscle is talking back. In fact, it's probably driving the boat on most of the things happening in your body. One way to think about this is that your brain is your control center, but your muscle is your factory. If you have adequate factory size, you're able to ship parts around the country, right? Your manufacturing is fine. You can handle changes in production. But if you don't have your factory under control, you're not able to make quick responses to things. So just to be very clear here, what I'm not saying is if you're 6 feet tall, you're a 22-year-old male, and you're 220 pounds, and you bulk up to 230 pounds, you're not going to get any healthier. You're not going to lose fat any faster. But if you are a client or working with a client who doesn't have sufficient skeletal muscle, adding on some skeletal muscle to them can be extremely beneficial for them for their fat loss. In fact, one of the first things that we do with clients is put them on a little bulking cycle or a little hypertrophy cycle to make sure they have sufficient muscle mass so that they have the ability to create these signaling molecules and mechanisms that tell their body to stop storing fat. Another way to think about this is a phenomenal article I like, and I didn't make this up. This is actually legitimately the title of the article. This was published in Cell Metabolism in 2008. But this article is called Bulking Up to Slim Down. I love the graphic that the authors put together in this paper because I think it illustrates our point very clearly. If we look at skeletal muscle hypertrophy and probably very specifically fast twitch skeletal muscle hypertrophy, what we see is the relationship between skeletal muscle and cellular function in the rest of our body. So as our first tab over here, we can see now, we understand that skeletal muscle controls things like glucose levels. Right? So you're working with someone who's having a hard time regulating blood glucose, and one of the questions that you can ask yourself is, do they have sufficient or well-functioning skeletal muscle? Now, I'm certainly not saying if you just put some muscle on some people, it cures all their diabetes or anything like that, but I will say it's an important mechanism. Look at the other things that skeletal muscle can do. It directly talks to adipose cells and helps regulate the size of adipose cells. So again, remember, adipose cells are your fat tissue. It can do things like reduce glucose, play with insulin and leptin and other things that regulate energy storage or energy use. Increase fat oxidation at the liver or other things. So I think it's really important that we take this stuff and understand that if we're talking about fat loss, probably putting somebody on an hour-long running program every day is not the most effective program. It can work and maybe should be a component, but probably not the most effective. We probably need a more well-rounded program that includes things like a little bit of hypertrophy work. I guess what I'm saying is, if I had to create a hierarchy of exercises that help me burn fat, it would probably look something like this. At the bottom of our pyramid would be the things that are probably the most effective and then that should occupy the majority of our training. And to me, those are activities that are short but require max or near maximal breathing, right? Something that makes you huff and puff a lot. Think intervals here. On top of that, probably not quite as effective but still very effective are things that help you build muscle. This would be more high volume resistance exercise, more repetitions, probably shorter rest intervals, things that make you burn quite a bit, increase respiration a lot, but also challenge a lot of muscles specifically. On top of that are things that are a little bit longer but require medium breathing, and then probably things, again, that are effective but probably least effective, especially when we consider per unit of time. In other words, bang for my buck, how many hours a day do I have to do? On top of our pyramid would be things that are long and require little breathing. Now, I'm personally of the opinion that variety is key here, so you probably should use all of these things, but the bulk of your program, maybe half of your workouts or more, should be down probably in this area, either things that are bulking or helping for hypertrophy and skeletal muscle, or more interval-based approaches, or some combination like that. And I think if we look at the literature, it supports this quite a bit. I love this paper. This was published in the Strength and Conditioning Journal from Dr. Mike Stone. Mike is a legendary sports scientist. And he took this actually from the Olympic Training Center in 2006. So what he did is took all the Olympic athletes that were getting prepared for the Olympic Games, and he wanted to look at how many calories per kilogram per day they were actually burning. And what he noticed is when he broke it up across all the sports that were at the Olympic Training Center, there wasn't really much of a difference between the caloric expenditure of all the athletes. Now this is pretty crazy to think, right? If we asked most people, and in fact maybe if I asked you this, said who do you think is going to burn more fat, a cross-country runner or an Olympic thrower, like someone that does the javelin, the shot put? Well, most people would think it's way higher, going to be hundreds of thousands of more calories for the cross-country runner, and it could be, but if we break it down per kilogram of body weight, it's not that much different. Same thing is true, by the way, for females. When Dr. Stone looked at the females of the Olympic trainer, he saw a similar trend. Numbers are a little bit lower, but that makes sense, right, physiologically. But the point is here, the overarching understanding here is that exercises themselves do not determine the adaptation. In other words, the exercise you pick to do in your program to help you or your client lose fat is almost irrelevant. In fact, it is completely metabolically irrelevant. The application of the exercise determines the adaptation. So how you do the exercise determines whether or not it will be effective at fat loss. I'm not really specifically talking about exercise technique here. Of course, that's clearly important. What I'm talking about here are things like how long did you do it for? How intense was the workout? How many repetitions did you do? How much physical work did you accomplish? So when it comes to selecting the actual exercise, if you love running, by all means run. If you hate running or if you have bad running technique, you do not have to run a step in your life to lose 100 pounds, right? Meet your clients here if you're working with an athlete. Pick an exercise that they really, really like, a movement that they like, that they can perform thousands of repetitions at, that they'll feel safe, that they will let themselves challenge themselves on, right? That they won't be hesitant about, and then program that a lot. Give them a lot of movement variety, but don't program them to do complex exercises that they are either uncomfortable with or that they don't know how to do or they have a technical limitation with. Because when you start doing a lot of repetitions, kind of heavy, with low rest intervals or for a long time, that poor technique or that self-limitation is going to make them not do nearly as much work, or they're going to get hurt. Right? So the actual exercise you pick to do is almost irrelevant in terms of physiological calorie burning. What's more important is how hard you work and how often you're going to do it. This is probably why I get so irritated or I'm so amazed when I see things on Twitter or Facebook that are stupid clickbait things like, top 3 exercises you have to do to lose weight, or best ways to trim your belly. What exercise do I do to lose that awful fat under my stomach? It's complete nonsense. Pick the exercise you want to do, you're technically sufficient at, that you like doing. The more variety, the better, but the exercise itself really doesn't matter. In fact, if you were to actually Wikipedia this, and I don't know if this is still up, but the last time I did, if you Wikipedia things like aerobic exercise, you would get a list of exercises, which is crazy to me because, like I just said, exercises do not determine adaptation. Application determines adaptation. So what makes it aerobic exercise? It has nothing to do with the exercise choice you select. What makes it aerobic is the way you do it. So if I went to this aerobic exercise page on Wikipedia, I should be being told how to perform the exercise or how to do the movements. It doesn't even matter which movements I pick. Right? Now, if we were to poll a crowd of all the people in your gym or all your friends or your family at your last family picnic, and we just ask them a simple question like, hey, do you think all the pictures over here, do you think that's all fat-burning exercises? They would all probably say, absolutely, that's what I need to do to lose weight, right? In fact, if you were to go to the doctor, and depending on how old you are, you may or may not have been to the doctor. But imagine that you have, or you know someone that's been to the doctor with a little bit overweight, and the physician says something like, hey Bob, you're really getting overweight. I'm gonna need you to start exercising. I'm gonna need you to get out there and get on that treadmill, right? I need you to start running, or get on a bike, or start swimming. Why are they telling me what exercise to pick? They need to be telling me how to do it. This is how long you need to do it. This is how hard. This is what I recommend in terms of your rest intervals, how frequent a week. Here's some basics of technique if you choose these exercises, instead of just giving me a list of exercises. Now, I would agree with you and your family that I would certainly say that those are pretty good exercise choices to make if you're trying to program fat loss. But I would also say, what about things like this? Right? I mean, look at these poor ladies, look at their faces. Do you think that their heart rate's not extremely elevated? Right? Of course it is. What's their ventilation look like? Are they breathing? They're doing a tremendous amount of work. To me, this falls under the category of excellent exercise choices to help lose fat. In fact, I would even stretch it out to go in farther to say, what about things like that? What about a deadlift? Depending on how you're doing it, in terms of, again, how many repetitions, how many sets you're doing it, how frequently you're doing it, this can absolutely be effective at stimulating or promoting fat loss. In fact, I won't go too far down the rabbit hole here, but I'm really fixated on this, and I would love to do an hour talk on just this slide right here. Maybe let me know if this is something you'd be interested in. But it brings about a really interesting discussion about what are some of these terms we constantly use in the weight room and in the classroom. For example, what does aerobic exercise really mean? What exactly is cardio? And what is resistance exercise? I challenge you right now, come up with a definition of these things. I've been doing this for years in my classroom and I've still never had anyone succeed. It's really, really hard to define what resistance exercise is, for example. Right? Is it anytime you're working against gravity? No, I'm doing that right now. No one would really consider what I'm doing right now to be resistance exercise. Is it anytime you're working against an external load? Well, again, a pull-up, right? Some people can't use anything more than their body weight for a pull-up. There's no added load there, but we would consider that to be resistance exercise. So it's really challenging. On the aerobic or cardio side of it, right, would you consider a 1 repetition maximum deadlift cardio? Most people wouldn't, and I certainly wouldn't. But what's that mean? Cardio means cardiovascular. You ever taken your heart rate after a 1 repetition deadlift? I guarantee you it's through the roof, but yet we don't consider it to be cardio. Right now, aerobic, you could say it's has to do with oxygen, but I promise you right now, ain't nothing you could ever do you won't use oxygen for. So those things get really, really challenging. I guess what I'm really saying with all this stuff is to hell with it. Don't worry about it. It's minutia. You're playing colloquial games about things that honestly don't matter for you or your client. Right? Stick to the basics here. Another way to think about this problem is look at the pictures on the top of the screen. Right? These are traditionally anaerobic exercises, and they're things that people associate with stuff that you do if you're playing a sport or if you're young. But if we think about things that you do for your health, we tend to think about pictures like this at the bottom. And so for whatever reason, we have this really skewed system that anaerobic exercises are things that you do if you're a sporting young athlete, and aerobic exercise is something you do for your health. It's completely misguided. Another way to think about this is, hey, lifting is something I do for muscle if I want to look good or play football well. I want to train my muscle, I go lift. I want to train my heart, I go run. Right? That's absolutely fundamentally wrong. That had no way is how your body works. Right? Lifting absolutely is a cardiovascular challenge. I promise you. Cardiovascular is also a muscle challenge. So we have to get ourselves out of this mentality that that's how things work. I promise you, if you can do that, your programs will be 800,000 times more effective. You'll keep people healthier, they'll reach their goals a lot longer, and they'll stay with you for forever because you're going to have these basic fundamental understandings. I guess what I'm really trying to say with all of this is that when you're talking about designing your workout programs to make sure you achieve fat loss, it comes down to 3 things. Number 1, you got to get work done. Pick whatever exercise, whatever duration, whatever days a week, multiple days a week, 1 day a week, intervals, rep ranges. All you got to focus on is getting physical work accomplished. Number 2, you've got to be consistent, right? The work's got to be done. And number 3, be patient. If you do all those things, I'm almost going to guarantee you, exercise-wise, you'll have a sufficient program as long as you're not overworking people. That's going to help them achieve all of their fat loss goals. Now, I know that that's not good enough for you, so I don't want to leave you without giving you some very specific recommendations for design numbers. Again, we'll talk about specific recommendations for food and calories in a bunch of other separate videos. So let's start with hypertrophy. I want to walk you through some of the very, very basics of program design when we're talking about hypertrophy, especially considering or with the idea that we're doing hypertrophy for the purposes of fat loss eventually. So some basic concepts here to pay attention to. Generally pick complex movements, and you want to have a fairly equal balance around each joint. So don't do all horizontal pressing or all hinging or things like that. You want a well-balanced movement around the joints. You probably want to pick somewhere between about 3 and 6 exercises per day, and somewhere between like 3 and 10 total sets per muscle group. This can be highly varied, but I'm just giving you some very basic fundamental starter guidelines. Now, generally, we classically say hypertrophy is optimized between 8 to 10 repetitions per set, but this number can be widely varied. You're welcome to go down to 5 repetitions or even as high as 20 to 25, but for the most part, stick between like maybe 8 and 15 reps per set, something like that. You're going to want to do this pretty heavy though, right? In order to hypertrophy muscle, you need 3 things. You need a metabolic challenge, you need muscle tension, and then you need some sort of minimal amounts of muscle damage, right? So the muscle tension here is what you're going to get with our heavy load, 70-ish to 90%, right? It's got to be kind of heavy. For a beginner or a novice athlete, you may even slide that down to 60%. That still might be pretty heavy for them, but the goal would be to start working your way up to higher things, all right? Now, you're probably not going to be doing 3 sets of 10 at 90%. That's really high. So if you're doing sets of 10 or 12, you're probably more like 70%. If you're doing sets of 5, you might be closer to 90%. And then at the very bottom there, you want to do maybe 2 to 3 times per week each muscle. So that should give you some basic guidelines for hypertrophy, if that's what you're focused on. Now, in terms of the method, they're infinite. All right, so the way that we like to talk about this is the concepts are few, but the methods are many. So, you could do things like vertical pressing, bent rows, deadlifting, squatting, horizontal pressing, lots of core and torso and stability work in through there. But one thing I do want to caution you against is minimizing weightlifting movements. So if you're a weightlifter, and what I mean by that specifically is Olympic weightlifting, you don't want to necessarily do snatches, clean and jerks, or any of their variations for sets of 8 to 10 to 12. Right? And I'm not saying you can't ever do it, or some advanced athletes can't do it, but as a general rule, for the purposes of fat loss, there's simply better exercises to pick. Right? They're fairly complex. There's a higher injury risk when the load is really heavy, and you're doing a lot of reps, and you're really tired. Right? It can be done, but just probably not the greatest choice. Now, you could do something like a snatch grip deadlift. That's fine. You just don't want to make the movements too complex, especially when they're throwing and catching things over their head. Of course, overhead squats, those type of variations, totally fine. The same thing with plyometrics. So these would be jumping and landing drills. You don't necessarily do these things for the sake of hypertrophy. So 3 sets of 10 of box jumps is not really something that's going to put you in your optimal hypertrophy range. Again, you can, but for most clients, most people, it's not what we're really looking to get. From there, I like to break this up into my next category. So if you remember earlier when I said there's 5 basic adaptations, so it's speed, power, strength, hypertrophy, and conditioning, I actually like to break up conditioning into 3 separate subcategories: anaerobic, aerobic, and then long duration. We'll start here with the anaerobic conditioning. Our basic concepts are as follows. We still want to pick complex exercises. The basic point here is we want to work a lot of muscle groups at the same time. This saves me actually physical time, so I don't have to be in the gym so long. Also, the more muscles I'm using, the more work I'm doing, I'm accomplishing my goal of achieving work, right? Producing work. So complex movements. This doesn't mean things like one-footed on a ball where I have to twist. By complex, I mean big muscle groups, a lot of them moving at the same time. Something like a deadlift, which is pretty simple, but still in this category would be considered complex because you got a lot of muscle moving, a lot of parts are going, all right? So complex movements or exercises, probably something like 1 to 10 exercises per day. So you don't need a lot of variation in your exercise per day here. It could be 1, right? Your Aerodyne, a classic exercise choice for this stuff. Maybe a prowler sled. Maybe that's it. Maybe you use only the prowler push or a sled drag is your only exercise choice for your anaerobic conditioning for that day. Now, I would still encourage you to have multiple different exercises throughout the week, especially if you're not a competitive athlete, if you're just doing this for the sake of fat loss, to enhance variety, making sure that you don't get overuse injuries by doing the same movement pattern over and over again. That's what I mean when I say balance per week. Probably somewhere between 3 and 15 sets per day. Again, this can be wildly variable depending on exactly what you're doing, but the intensity needs to be at something like at or above your VO2 max. This quite literally means it's anaerobic, right? So something that makes you get really, really, really hard. Now, if you don't know what your VO2 max is, don't worry. This is something like, 80, 90, 95% or higher of your max heart rate, right? Don't have to measure it. You don't have to put a heart rate monitor on. Just go as hard as you can, all right? If you feel like you're going to throw up, that's probably pretty good. You don't have to go to 99%. You're probably going to get equal weight loss out of 92% as you are 97%. So just work hard, be safe, but work hard. Now, what makes anaerobic conditioning specific is this work to rest ratio. Now, this can swing anywhere from something like 3 to 1 all the way out to 1 to 5. But the key is the duration of the exercise is probably somewhere between 5 and 60 seconds. Now, I'm trying to be very soft on all these recommendations because there's no magic here. There's nothing that says 61 seconds is not anaerobic conditioning, or you can't go 4 to 1 or 1 to 6, right? I'm just giving you ranges to generally play in. So let's make this work to rest ratio example very, very easy. Say you did something like 30 seconds of work as hard as you can with 30 seconds of rest. 30 to 30 means a 1-to-1 work ratio with 30 seconds of work. That falls perfectly in our anaerobic conditioning. Right? You could also do things like I did with my friend Mike McGoldrick very recently, where we did 10 seconds as hard as you can, but 50 seconds off. And then you do that for 10 or 20 minutes. That would be like a 1-to-5 work ratio, so 10 seconds of work, 50 seconds off. Or you could go the other direction and do something like maybe 30 seconds of work with 10 seconds off. Right. Now, there's pros and cons to those. They are quite different, but the point is you're getting a lot of work done. Okay, and then lastly for our concepts is you probably want to do about 2 to 5 different times per week to do this. With your novice people, maybe the most they can handle is 2 sessions a week like this. You got a highly trained athlete or at least an experienced exerciser, you might be able to pull this off 5 times a week. But I would say your average person, in fact, the research has shown quite clearly, twice a week for as little as 4 weeks can show significant improvements in fat mass. So maybe 2 to 3 times a week is probably a good number to shoot for here. In terms of the concepts, I mentioned this or I alluded to this a little bit earlier ago, in terms of the methods you can pick. But you got a lot of variety here. You could use kettlebells or dumbbells, or you could do some sprinting, a rower, a sled, basically any exercise that allows you the confidence and tactical ability to go as hard as you possibly can for some sort of short duration. All right. Again, we're not really gonna use weightlifting or plyometrics in this set because of the risk factor. Generally, again, we can be used. But what I'll also add to this one is a little bit of a pro tip. Try to select exercises that are primarily, or if you can, only concentric. Now, to understand what I'm saying here, concentric versus eccentric. So concentric is when the muscle shortens. Eccentric is when the muscle lengthens. So for example, when I am pushing a prowler, I'm not landing very much on the ground. I put it on my foot on the ground softly, and then I push hard. I concentrically push, as opposed to something like a jump where I land and have to absorb that landing. If you do this, I promise you will never be sore in your life. Well, maybe that's not true, but you'll be tremendously sore. I want you to do 30 on, 30 off, 5 rounds of this, and I want you to do vertical jumps. So for 30 seconds, I want you to jump as high and as fast as you possibly can for 30 seconds. Take 30 seconds break and do it again. Come back tomorrow and tell me you're not ripping sore, right? Eccentric actions make us really damn sore. So if you do that at this volume, at this intensity, you're going to kill your clients. Only young, healthy 22, 25-year-old athletes are going to be able to handle that. The rest of the population is going to get crushed and never come back for 5 weeks. All right. So pick things like a rower, which again, there's no absorbing, there's no landing in a rower, there's only pushing. Same thing with a sled or a bike or an aerodyne. You can work your ass off with those things and you're not going to be tremendously sore from them because there's no landing and absorption. Right? You catch a bunch of front cleans or cleans in the front squat position, you're going to get pretty sore there. In terms of aerobic conditioning, it's very, very similar to anaerobic, but essentially what we've done is stretched out the time length of the work. right? So again, we want to do complex, big, important movements. Probably only going to do 1 to 3 exercises per day. You're not going to really do a bunch of variety here within the day, but you do want to balance this throughout the week. Maybe something like 1 to 5 sets at or equivalent to your VO2 max. Did I catch you right there? All right, a huge mistake people make here is thinking aerobic conditioning is submaximal, and that's not true. If you want to challenge your maximal aerobic capacity, you have to work at your maximal aerobic capacity. Aerobic conditioning is not easy. It is not submaximal. This is at your VO2 max, or again, at your max heart rate, or something like that. We'll get to the submax stuff in just a second. Your work to rest ratios probably makes more sense to be something like 3 to 1 to 1 to 1. You're probably not going to do like 2 minutes of work and then rest 20 minutes. It's going to be like a 7-hour workout. So maybe something like 3 minutes as hard as you can, 1 minute off. Or 10 minutes as hard as you can, 10 minutes off. Maybe something like if you've ever done a 1 mile repeat. So run a mile as fast as you can, take that exact amount of time off, and then do it again and do 3 or 4 or 5 rounds of that. You want to lose some fat mass, oh my gosh. This aerobic conditioning stuff is brutal. You can probably only do about 2 to 4 times per week, again, because this is a lot more challenging than the anaerobic conditioning stuff. It's just a lot more volume, right? It's a tremendous amount of work, exponentially more work being done here. Your beginner athletes, maybe once a week, your beginner clients. Even your advanced folks, maybe twice a week is still enough. In terms of the methods that you select to actually get this stuff done, just like the last slide, very similar. Anything you can do maximally. We want to minimize the weightlifting movements. Absolutely minimize, no jumping here. Minimize landing and stay concentric for as long as possible. Okay, so now that we've described anaerobic conditioning, we've described aerobic conditioning, the last thing that I'll put under the conditioning banner is what I'll call long duration conditioning. Some people call this long slow. I hate that term, but it's long duration conditioning. So this is any movement, really tends to be more simplified movements because you have to do it longer. So something like running, maybe cycling on a bike. These are fairly simple, small muscle mass movements. It's probably 1 exercise per day. You're not doing multiple exercises per day, but you might have a couple of different exercises you choose from each week. It's 1 set. It is submaximal. This is not to say it is less efficient or less effective. All right, I'm not downplaying it here. I'm not minimizing it. It's continuous work, though. It's probably 15 minutes or more of steady state, for the most part, work. Right? Probably up to even 30, 45 minutes, up to an hour for most people, but even an hour is stretching. And I think 30 to 45 minutes is a good number. You could probably do this fairly frequently. It's not too dangerous or too hurtful on the body if your movement is good, if you move well, right? So if your running technique is good. You want to emphasize sort of moderate to slow reps because you want to be able to make it for 30 minutes. You don't want to have to stop at 12 minutes and be done. The idea here is to sustain and to not stop at all. So your basic movements are the same. Anything you can do for 15 more minutes that you're technically and tactically capable of doing. Of course, this eliminates weightlifting. It eliminates plyometrics for the most part. And again, we want to try to stay concentric. Running is the big banger here, right? If you aren't used to these types of things, do not send a client out to run for 45 minutes. Don't even send them out to run 20 minutes if they're not used to it. Their quads are going to be crushed the next day because of all the eccentric landing. Earlier, I listed patience as one of my 3 important keys to successful weight loss. Well, what allows people to be patient through this process is having a realistic understanding of how fast the weight loss is going to actually occur. So I wanted to show you what this should possibly look like and to give you some successful weight loss tips. All right, first and foremost, it's trial and error. Now, this is true for the exercise program stuff, which we talked about here, but it's also true for the nutrition. There is not one system that works for everyone, and what's even crazier is there's not one system that works for every one person. Right? The same program, the same exercise, the same habits that worked one time or to help you lose the first 20 pounds maybe won't help you lose the last 10. I remember giving a seminar a few years ago, and there was a lady in the stands. She asked me a great question, and she said, I just lost 65 pounds the last year, and she was maybe 20, 30 pounds overweight at the time. She said, I lost 60 pounds already, but I've been at this plateau for like the last 5 months. And I said, oh man, first of all, that's great, but Well, what have you changed in the last 5 months? And she said, well, nothing. So what do you mean? She's like, well, I lost the first 60 pounds following this exact program, and I didn't want to change it. Well, it worked for the first 60, but it's not working anymore, so we've got to change things, all right? So you got to make sure that this is always a trial and error process. There has to be some sort of energy deficit, right? We talked about that. There's got to be less carbon coming in than there is carbon going out. All right, so this is probably best with a combination of excess carbon going out via exercise and less carbon coming in via less food. Now, I'm not saying less carbohydrate, although that is one option. I'm just saying less food in general. So you should aim for a caloric deficit of something like 10 to 15%. Do not make huge cuts in calories. I worked with a gentleman years ago who was probably 450 pounds. And we met for the first time, and I said, all right, walk me through what you do, what your normal day looks like, Nate. This is the no judge zone here. Just tell me the truth. And so he said, well, on my way to work, I pull over at, of course, a fast food restaurant. And I get 2 egg McMuffin sandwiches or something, and orange juice and hash browns. I said, okay. Well, tomorrow, let's try to make a change. And he said, yeah, so tomorrow I'm going to go there. Instead of getting my 2 egg McMuffins, my hash browns, and my orange juice, I'm going to get half a hash brown and the orange juice and a bite of one of the egg sandwiches. And I was like, whoa, 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 whoa. That's like an 85% cut in calories. That's a horrible idea. What I want you to do is go from 2 egg sandwiches, hash browns, and orange juice to orange juice, hash browns, and 1 3/4 of an egg sandwich. Right? 10 to 15% is the most you're going to get away with. I promise you, I've done this a lot. Right? In terms of the weight loss, you should be shooting for something like losing about 0.5 to 1% of your body weight per week, which for most people is usually like 1 pound to 1.5 pounds per week. That's probably a good number for long-term sustained weight loss, not rapid weight loss for 2 weeks to make weight for competition. But if you're working with a client who's interested in losing weight over time, if they are tremendously big, again, you're 300-pounder, you're 50% body fat, you might lose 2 to 3 pounds a week, but that's really, really rapid. Even 0.5 pound per week is a good number. Right? What's sort of interesting, I always tell people, what if I came up to your friend or you yourself and I said, hey, I guarantee you I can get 20 pounds off of you in the next year, or I can lose you 40 pounds in 2 years. People would be like, damn, oh my God, I would love to lose 40 pounds. And they'd be happy. But if you said, hey, what if I can guarantee you 0.5 pound a week, or maybe 1.5 to 2 pounds a month? They're going to be like, get the hell out of here. Terrible. I'll pay somebody else. Right? So people have a hard time grasping that number, but I'm telling you, this is the realistic number of what's going to be successful long term. A quick note on nutrition. I would recommend that you do not minimize carbohydrate unless you're under special circumstances, but you might play on the moderate to lower end of your carbohydrate recommendations. All right. Make sure that you maximize protein or keep that very, very high, as well as your minerals and your vitamins. Fat and carbohydrates are the one you could probably play with. Right? So if you want to go a little bit lower carb or a little bit lower fat, you don't want to eliminate either, generally, unless you're going on a very specific diet plan, which you can do. There are some out there that are effective. But for the average person, just get them on the moderate to lower end of the recommendation for the carbohydrates. Keep protein high or higher. Keep minerals and vitamins and a bunch of other things like that really, really sharp. And then lastly, make sure that they can enjoy food and have a social life. Again, if we're trying to talk changes in habits over time, changes in lifestyle, you can't cut out your friends. You can't cut out every piece of cake or glass of wine or every cheeseburger the rest of your life. And for most people, that's just not going to work. I realize there are some out there that can do that. I'm actually fortunate. I can. I don't have a hard time really with that. But most people, that's not going to work. In fact, most people, when you restrict like that, it makes the problem even worse. So to put my money where my mouth is, I wanted to show you some of the things that I've actually done myself. So this is the chart of my body weight getting ready for national championships in weightlifting in probably 2010, something like that. I can't remember exactly. Maybe a little bit before. Wait. No, more like 2007. I can't remember. But here's the point. I started off at about almost 180 pounds and had to get to 151 pounds. So that was about 28 pounds or so I had to lose. You see, I started out here in the end of December and had to get to that weight by essentially get all the way down to my weight by, I think I had July or something like that. Well, I cut off the chart just to make you think, but what you can see here is if you look at my chart, you can think, man, you're so smart, you have a PhD, you lost weight perfect, everything went great. You had this linear loss of weight. But that's not what happened at all. In fact, look at that time frame right there. From January 12th to March 9th, I came into January at something like 175 pounds, and I walked out of March at like 173 pounds. Right? And you can see, look at the day-to-day variations. I mean, I'm all over the place here. I knew I had a long time, so I wasn't being tremendously strict. I was just trying to be good, knowing that, look, over time, because I started really early, I'm going to get down to where I need to be eventually. Right? So what's happening with you or most of your clients is, if they're frustrated and they're not losing weight, you're probably zoomed in too far. Right? If you zoom into this graph right here, you're like, ah, shit, 2 months or a week and a half or something, and my plan didn't work. But if you zoom out far enough, that weight loss line starts to look like a perfect linear decrease. Right? So again, zooming in that picture there, and you're like, oh my gosh, you're not losing any weight, you're at the same weight, but when we zoom out, everything looks all hunky-dory. In fact, you can even know a few days over here where some bad things happen. Turns out there's something pretty awesome that happened sort of the middle of January or the middle of April there. My birthday. All right, so maybe we had some problems. There may have been a Vegas trip in there or something like that. I can't really remember. Okay, so be patient. You're playing the long game here. You're playing the big picture. I want to end this episode of 55-Minute Physiology by going all the way back. This is one of my favorite books of all time. This is Galen's Hygiene. If you don't know who he is, he's one of the fathers of physiology, or certainly of exercise physiology. Some would give him that credit. But this book is phenomenal if you ever get a chance to read it. And what I've done is I've actually taken a passage out of it, and I want to read it to you because I think it just blows my mind how well he understood physiology thousands of years ago. So let me walk you through this. Quote, "To me, it does not seem that all movement is exercise, but only when it is vigorous." Right? So just because you're moving around, just because you take the stairs or you park a little bit further away in the parking lot, that doesn't necessarily make it exercise. It has to be vigorous. This is the difference between physical activity and exercise. But since vigor is relative, the same movement might be exercise for one and not for another. So for me to park at the end of the parking lot and to walk into the store, giving me 5 or 20 extra steps, that's not necessarily exercise for me. But for some folks, that might be enough. So keep that in mind. One of the best pieces of advice I can give a young trainer or a coach is to not project your abilities and your skill set onto your clients. Have some empathy and sympathy for what they're able to do, and make sure you really pay attention. It's probably hard, especially when you're young, for you to realize what's it feel like when you're 55 years old. Right? So a workout that you think, oh, it's not bad for me, it might be exhausting for them. Right? So it's relative, so let's keep that in mind. Going back to the book. The criterion for vigorousness is a change in respiration. Those movements which do not alter the respiration are not called exercise. So you want to know what's a quick way to tell you're exercising? Does it change your respiration or not? Right? I love this when you go to the gym and you see people on the elliptical and they're reading a magazine. Right? They're on the stair stepper, probably not the stair stepper, that one's kind of hard. On the treadmill, whatever it happens to be, on the bike, right? Cruise around the bike. If it doesn't change your respiration, it's not exercise. But, back to the book here. If anyone is compelled by any movement to breathe more or less faster, that movement becomes exercise for him or her. Now, according to Galpin, he says, quote, "The uses of exercise, I think, are twofold. One, for the evacuation of excrements." What he means there actually is not like those kind of excrements, not like going to the bathroom, but he means by losing fat. We are trying to evacuate the excrements, right? And I'm not going to sufficiently evacuate excrements if I'm not raising respiration. Beautiful, right? He got this whole carbon in, carbon out thing thousands of years ago. Right. Quote, "And the other is for the production of the good condition of the firm parts of the body. I don't mean those firm parts of the body. He's talking about muscle here. Hypertrophy, fat loss. That's why you exercise. Most people. And finally, quote, and from the vigorous movement of respiration, the ducts must be purged and the excrements can be evacuated. In other words, breathing out CO2. I hope you enjoyed this installment of 55-Minute Physiology. I know this was a bear. Hopefully I inspired you to go look up some other things, to go explore exercise physiology and biochemistry. Stay tuned for next time. If you got any questions, of course, let me know on social media, Instagram, Twitter. You know the drill. Facebook, post it up here anywhere you have to do. Let me know if you have any thoughts or questions. I thank you for staying along for the ride for this long, and we'll see you next time.